Welcome to the training module on electrostatic discharge or ESD and electromagnetic interference or EMI protection. This training module will introduce the knowledge of ESD and EMI protection and TI's IPD product portfolio. As you can see from the animation, that the human body model test is exactly what it sounds like. It is as if the ESD strike occurred through a human touch. The typical ESD strike value is 2000 volts. From Wikipedia, the human bodied model or HBM is the most commonly used model for characterizing the susceptibility of electronic device to damage from ESD. The model is a simulation of the discharge which might occur when a human touches an electronic device. Machine model testing requires a specially designed load board which interfaces with an automated high pin count ESD tester. Each pin is tested with high voltage and high current ESD shocks, while other pins on the board are held to ground. Essentially, each pin is zapped with respect to groups of independent power and ground supplies, as well as each pin being zapped while all the other I/O pins are grounded. Charged device model test is not so commonly used anymore. This method simulates what happens in an automated manufacturing environment when an IC becomes electrically charged and the part discharges when it comes in contact with a grounded conductor. The CDM discharge is very fast transient, which takes place over a couple of nanoseconds. This is a more challenging device to model and is based on the size and the capacitance of the IC being tested, with little impedance to reduce the current. This can result in high current well above 5 to 6 amps being discharged in short duration of 1 nanosecond or less. Thus, this stands as the most practical real-world test for ESD issues today. The three models are represented here, where HBM has the longest pulse width of 150 nanoseconds, followed by the MM at 80 nanoseconds and CDM at 1 nanosecond. The rise time are also different. The CDM rise time is at less than 400 picoseconds and much faster than the other models. Note again that the damage phenomena to HBM and MM are the same but different from the CDM. IEC stands for International Electrotechnical Commission. Out of these specifications, TI regularly tests the -2 ESD immunity test and started to test the -5 test for surge immunity. If it comes up as to why we don't test the others, it's because we haven't found it necessary. If someone is interested in knowing how devices perform under certain standards, TI would be happy to suggest it to the team to see if they would be willing to attempt it. The gray line shows the human model test. It lasts about 150 nanoseconds and is about 1.3 amps at its max and tests normally at 2000 volts. The black line shows the charged device model test. It lasts 1 nanosecond, is about 2 to 5 amps depending upon the package, and tests normally at 2000 volts. The red line shows the IEC ESD test, which has two main portions. First, it has a 30 amp 15 nanosecond peak and then a second pulse of 16 amp peak that lasts the full 150 nanoseconds. So long story short, we consider the IEC level tests the ground standard in ESD tests, which is why we show this most prevalently. With advanced process, we need more die area to design the same IEC cell. You can scale down the core design, but you can't scale down the IEC cell. This makes it much more expensive to try and add an 8 kilovolt IEC cell into a core design. RF section of portable equipment generate conducted and radiated EMI interference. Non-optimized board layout often generates EMI interference among signal lines. EMI interference can cause both functional and reliability failure. So an EMI filter is simply a low-pass filter. It allows the signal to effectively pass with low loss and attenuates out the unwanted EMI and RFI signal interference that once was present. Some people like to discretely lay out their EMI filters and ESD protection devices through resistors, capacitors, and diodes. We combat this by offering significant board savings compared to this, and we ease the headache of trying to do the layout for all of that. In the example of an 8-channel EMI filter, each channel would have 5 discrete devices, so the whole thing would total 40 discretes, making this a layout and solder nightmare. Integrated protection devices can be found in almost any application, ranging from personal media players to TVs and set-top boxes, computing, wireless handsets, communication peripherals, medical electronics, automotive, digital camcorders, and so many others. We've listed some key considerations: breakdown voltage, normal Zener-diode IV relationship, breakdown voltage highlighted at ramp current. The IV curve of a snapback is specific with TI. You can apply more DC voltage so you have a lower voltage than a Zener diode, making us the only one in the game with something like this. This slide shows how much growth there has already been and will continue to be in the area of interface protection devices at Texas Instruments. TI offers application-specific ESD EMI solutions that are compatible with the core microcontroller or connector interfaces. TI can demonstrate ESD EMI compatibility in reference boards based off TI core chipsets. They can integrate many of the discrete components, active and passive, on your board. TI also offers reliable second source options in the ESD and EMI areas. Texas Instruments has more IPD devices released in other industry standard packages. These diagrams illustrate how small these devices can be. The TPD4S012 is a 4-channel electrostatic discharge solution for USB charger or USB on-the-go interface. In many cell phone applications, the USB connector is the de facto communication port for external communications like high-speed data transfer, audio signal, charging, car kit, etc. In order to support different interfaces, the USB port needs to handle different voltage levels. For example, some chargers require the V-bus port of the USB connector to handle in excess of normal V-bus voltage per USB specification. The TPD4S012 offers combinations of 2 different clamp voltages to match the voltage tolerances of the different signal interfaces using the common USB connector. The TPD2E009 provides 2 ESD clamp circuits with flow-through pin mapping for each board layout. This device has been designed to protect sensitive components which are connected to ultra-high-speed data and transmission lines. The TPD2E009 offers protection from stress caused by ESD. This device also offers 5 amps peak pulse current ratings per IEC 61000-4-5 specification. The TPD12S015 is an integrated HDMI ESD solution. The device pin mapping matches the HDMI Type C and Type D connector with 4 differential pairs. This device offers 8 low capacitance ESD clamps, allowing HDMI 1.3 data rates. The integrated ESD clamps and resistors provide good matching between each differential signal pair, which allows an advantage over discrete ESD clamp solutions where variations between ESD clamps degrade the differential signal quality. The TPD7S019 is an integrated 7-channel ESD solution for the VGA or DVI-I port connector. This device integrates ESD protection for all signals, level shifting for the DDC signals, and buffering for the sync signals. 3 individual supply lines control the power rails of the video, DDC, and sync channels to facilitate interfacing with low voltage video controller ICs in mixed supply voltage environments. The TPD2F702 is a 2-channel EMI filter for audio interface applications. With the integration of 5,000 picofarad capacitor in space-saving low-noise WCSP package, the TPD2F702 offers superior EMI noise suppression between 2 MHz to 6 GHz compared to discrete implementation. The device is optimized for AVIF connector or speaker port interfaces. This low-pass filter array also provides system-level ESD protection to eliminate the need for external ESD clamps. The TPD2F702 exceeds plus or minus 30 kV ratings per IEC 6100-4-2 contact and air gap specifications. It is primarily used in the mobile phone audio headphone speaker interface, but can be used in other audio applications. The PicoStar package is as thin as a human hair, so this allows for unprecedented things to be achieved, like embedding the device in the PCB. This device is an application-specific integrated part designed to offer system-level ESD solutions for a wide range of portable and industrial applications. The back-to-back diode array allows AC coupled or negative going data transmission for audio interface, LVDS, RS-485, RS-232, etc. without compromising signal integrity. The PicoStar package is intended to be embedded inside the printed circuit board, which saves board space in portable applications. This device exceeds the IEC 61000-4-2 ESD protection and suitable to provide system-level ESD protection for the valuable internal ICs while placed near the connector.